So the task is about learning local models for data scientists. So we have 4 data scientists, which are Isabella, Helene, Emily, and Annika. And each of these data scientists has her own local data set. And you find these local data sets also on my GitHub. So let me go again here. So let's see, Alex Young, GitHub. You find the links then also in the notebook, the precise address. So I have put it here for quiz federated learning flavors. Yeah, so you find here 4, these are comma separated files for each of these data scientists, and they indicate the data scientist in the file name. So here's the local data set for the data scientist Annika. And yeah, all these 4 data scientists look at the same type of data points. In particular, each data point is described by 2 numeric features, x1 and x2, and a numeric label value. So it's a regression. They all look at regression problems, and they all look at data points that are characterized by the same type of features, x1 and x2. However, some of them have only access to x2, like here Annika. She has no access to x1. She was not able to access the feature or the measurement x1, which is missing here. But she has access to feature x2. And then let's look at Emily. Emily has local data set also of the same type, and also she cannot access x1. So Helene should then have, yeah, this is an example of a local data set where x2 is missing. Yeah, what can we say about the data set, about the local data set of Helene, for example? It seems there are 2 numeric features, and there are a lot of data points. So your task will be to use federated learning to learn for each scientist, for each local data set, a linear hypothesis map. So you must learn weights W1 and W2 that are used to linearly combine these 2 features to predict the label with a minimum squared error loss. So this is linear regression. And when you look at this local data set, what do you think? Is this a large data set? So we have 2 features, nominal features, and more than 500 data points. What's your analysis? What's your diagnosis as a federated learning engineer? When you come across such a local data set, is this a large local data set for training a linear regression model? Yeah, so there are two comments here. No, quite small, and another one large enough. So why do you consider it quite small, the local data set? So we have data points characterized by 2 features and more than, so I can say it's around 1,000 data points. So an Alex rule of thumb is the number of data points in your training set must be 2 times larger than the dimension of the model. And for linear regression, a good quantity or a good measure for the dimension is 2, or any reasonable measure for the dimension will result in number of features in general without further assumptions. So we have way more data points than the dimension of the model. So from this perspective, we should not use any federated learning. We just train the model. But what do we do with the missing data? Well, it turns out, and this you actually have to find out, some of these local data sets are based on the same samples, so are based on the same data points. So your task is to find out which local data sets come from the same underlying sample or data points, and then you can use those to somewhat impute the missing features. And you will find out, I can tell so much, that this results in a better performance than just ignoring the missing feature and say, okay, here, I don't have any access to X1, so I kick it out of my model and I only use this feature X2. And I train a linear regression model that only uses X2. You can try that out, by the way. And you will find out that using federated learning, so in particular, you have to use So I also specified a bit more in detail. You have to build an empirical graph, a network X graph, which is already done in some starter code here. So you have to, so I now need to check if I have added, no, the solution is not here. Oh, thank God. Yeah, you have to build up an empirical graph, and then you have to use the nodes of an empirical graph, and then you have to place two edges. You are allowed to include two edges in your empirical graph. So this is a design constraint by me. And you have to place them some between two different nodes. So you have to place two edges, and then you're only allowed to use this ready-made implementation of federated stochastic gradient descent to learn weight vectors. And you have to learn a weight vector of length 2 for each data scientist. One weight vector for Annika, one weight vector you have to learn for Helene, one for Emily, and one for Isabella. Okay, and yeah, the quiz then, I will open it next week. So the deadline stays the same. It's the 5th of April. Will be most likely about testing if you got good weights. Because I know there's an optimal choice for the weights, because I, of course, engineered the data sets. And the quiz will be testing how close you are to the optimal weights. Yeah, I will open the quizzes until Saturday. Yes, also for the previous quiz. Sure. Any questions? Yeah, don't worry. If you, for some reason, mess up a quiz, you will always have the opportunity to review quiz questions, to discuss and compensate for missed points. You can submit solutions to the exercises in the lecture notes. So I don't want you to stress unnecessarily with the quiz questions. They are mostly meant to do efficient grading for the bulk of students. But if for some reason or the other, it's hard for you to meet the deadlines, yeah, and by the way, we will make no excuses with the deadlines. They will be strict, period, because you will have many other opportunities to collect points to compensate for missed points in the quizzes. Okay. Any other questions, comments? Yeah, by the way, I have now decided that the project will be allowed also in groups of up to 3 students. So you can do a project with 2 colleagues together. Okay, if anything else comes up, please use our Slack or email. And yeah, I wish you then a nice evening and try to get some sunlight. Bye.